5-1 is where the fun is. Good morning. So we finished off with a little bit of multiplying. And this is just a 5-1 continuum. And we were talking about things like two binomials multiplied together.
When we're doing the adding and subtraction of the polynomials, and you have one on top that's minus a negative polynomial, if the second polynomial is negative also, would that minus sign change that?
Changes all the signs.
Changes all the signs.
Because you're distributing -1. Let me write it over here. If you have like x squared minus 3x plus 2 minus x squared plus 4x minus 5, right? Put a 1 here, distribute -1. What's it change? Well, that becomes -x squared, this becomes -4x, and this becomes +5. You change all the signs.
So we're distributing a negative.
Yeah, and in this one, technically, you're distributing a +1 through. Either way, you want to get rid of the parentheses, and the only thing that gets rid of parentheses is the distributive property. For instance, this one. Now, it's up to you if you want to do FOIL. That's great. If you want to use the technique that I suggest, which is just distribute, good morning. You could do that too. The pattern is exactly the same. So when you multiply these two together, you get 3x times 4x is 12x squared. And then you get 3x times +5, which is a positive 15x. You really want to say positive and or negative because it'll give you the operation, whether it's addition and or subtraction. So here we've distributed the 3x over the second binomial. And next, of course, is the -2. So -2 times +4x is -8x. And -2 times +5 is -10. So this is what's a general binomial times of binomial. And generally what happens is these middle two terms will add together. But it's not always true. The only thing, I could just change one thing up here and the two middle terms wouldn't add together. I could write this as 3x squared and all of a sudden you couldn't add the two together and you'd have a 4-term polynomial. But this one does, which is nice. 15x minus 8x? 7x, what property? How many times do I have to say it? Combining like terms is? What property? Combining like terms is which property?
Distributive.
Distributive property. You're kicking the x out, and then you get the 15 minus 8. So this is 12x squared plus 7x minus 10. And that's it. That's all you have to do. Now there's a few little twists that you can play with these polynomials to, throw people off. Twist number 1 would be this. What if I wrote 4x minus 2 squared? What's the common mistake? Well, believing that this is a law of exponents. The law of exponents says, well, if you have everything on the inside that's multiplied together, you take everything and you square it. So some people look at this and go, oh, this is 16x squared plus 4. But is that right? No, because this has a subtraction and it's not all multiplication. So the best thing to deal with is to write it properly, which is 2 factors of the base, which happens to be 4x minus 2. So just copy it down twice. Then it, oh, and then FOIL. So 4x times 4x? 16x squared. And then 4x times -2? -8x. -2 times +4? Another -8x. And finally, -2 times -2 is +4x. Now, I love this. I've seen people go -8x minus 8x is 0. But they're the same sign. It really should be -16. So this is 16x squared minus 16x plus 4. Can you go any further? No. So if you see a perfect square, make sure you write it twice. Don't try short-stepping it. Copy down 2 factors of whatever that base is. Guess what happens if it becomes cubed? You have to write it 3 times, and then it gets a little uglier. So I have to show you what happens if it goes uglier. This is when FOIL doesn't work anymore. When FOIL doesn't work. Well, all you have to do is get away from a binomial times a binomial. So what about 2x minus 3 times x squared plus 5x minus 7? A binomial times a trinomial. Well, the only thing that's going to work here is the distributive property. And like I kind of outlined with FOIL, I don't usually use FOIL. I just kind of distribute the first term over the other polynomial, and then the second term over the rest of the polynomial. So here, basically all I'm going to do is distribute 2x over x squared plus 5x minus 7. And then I'm going to distribute negative 3 over x squared plus 5x minus 7. So this distributive property is actually much more powerful than FOIL. So we're going to take this 2x, we're going to distribute it. 2x times x squared. 2x cubed. 2x times positive 5x. What do I put here, though? Plus. It's a positive 10x squared. All right, and then finally, don't forget this one, 2x times negative 7. A negative 14x. All right, the next one is your choice. It depends on your style of doing polynomials. We're going to distribute the negative 3, and the first one we get is negative 3x squared. Where you put it depends on the style you're going to do. You can put it here at the very end, and you'll have this really, really long polynomial, and then you have to go back through and combine like terms with what property? Distributive. Yay, we're all on the same team there. Or you can line it up so that the combining like terms becomes easy. So I choose to take this negative 3x squared and put it right here, so that I keep my x squares next to each other. And that way I don't have to go searching all over the place for all the like terms. And then this usually works out rather well. Negative 3 times positive 5x. And if you put it here, it lines up perfectly with the x power. Now this doesn't always work nicely. You sometimes have to move things around to get them with the like powers. But generally they work out rather nice. And then finally, negative 3 times this negative 7 way down here. And that kind of just hangs off the end. And then you can just add them together. So you get 2x cubed positive 7x squared negative 29x plus 21. There's your answer. Generally, it's not much more difficult than a binomial times a binomial. It just takes a little bit more writing and a little adding at the end. Sound good? All right. So now we can do things that look like this. 2x minus 3 cubed. You have to write it out 3 times. The product of 2x minus 3, or 3 factors of 2x minus 3. Probably the easiest way to say it. 3 factors of 2x minus 3. Again, it becomes a choice. You can only multiply 2 of these together at once. So you either A, multiply the first 2, or B, multiply the second 2. Which one would you do? Which one would I do?
Second.
Why?
Because you're difficult.
No, not because I'm difficult. Because I know I want my setup to be a binomial times a trinomial. If I multiply the first 2 together, I'm going to get a trinomial in this position and a binomial in the second position. So my choice, I always multiply the second 2. Just so it lines up correctly. Even if you multiply the first 2, you can take the whole thing and flip it. What property?
Distributive.
Commutative. Distributive. Yeah, you're just going to say distributive all the time now. So I'm going to multiply the last 2 first. So 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is another negative 6x. And negative 3 times negative 3 is positive 9. Combine like terms, and we're going to get this new polynomial of 4x squared. Careful.
Minus 12x.
Minus 12x. And then finally plus 9. Don't forget the binomial that's sitting up front, which is 2x minus 3. All right. And then just distribute 2x minus 3 over 4x squared minus 12x plus 9. So 2x times 4x squared,
8x cubed.
8x cubed. 2x times negative 12x,
4x squared, negative 24x squared.
negative 24x squared, be careful of your powers. 2x way down here times positive 9, plus 18x. And then we're done with the 2x. And we work on the negative 3. Negative 3 times positive 4x squared. Negative 12x squared. Negative 3 times negative 12x. Positive 36x. And negative 3 times positive 9. Negative 27. And add them all together. 8x cubed.
Negative 36x squared.
Negative 36x squared.
Plus 54x.
Plus 54x. Minus 27. And there's your answer. Most people don't have a problem multiplying, adding, well, you know, for some reason people have problems adding and subtracting polynomials. Usually because they see two parentheses and they try to multiply them together. But most people don't have a problem. Let's make sure I covered all the possibilities. Yeah. Ooh, I never asked you to do that one. Okay, so multiplying is not a big deal. So let's see, we did addition, subtraction, multiplication, so next up must be
Long division.
division, and we have to do it by long division. But before I jump into long division, I do want to show one other possibility. It's a simplistic type of division. So this is 5-2, poly division. Oh, let's see here. 16x to the 4th minus 12x to the 3rd plus 20x to the 2nd minus 4x plus 8. All divided by 4x squared. Yeah, let's just make this 4x. Let's get rid of the 8. So don't put the 8 there. Alright. For some reason, I don't know why, this causes difficulty with people. They see that 4x and they see that 16x to the 4th and they cancel, and then they don't divide anything else. What property is being applied to this fraction? Distributive property. This 4x in the bottom is dividing each one of the terms on the top because technically this long fraction bar represents a set of parentheses. So the entire top is being divided by 4x. So you have to do each individual term separately. So you just start off pretty simply. 16 divided by 4? 4. That would be 4x cubed because one of the x's would go away.
Oh,
Minus negative 12 divided by 4 is a negative
3x
3, and we lose a factor of x. 20 divided by 4 is a positive 5. One of the x's go away, and you're left with 5x. And then finally, negative 4x divided by positive 4x is negative. You're dividing. You're dividing. It's negative 4x divided by positive 4x, which is negative 1. And there's your answer. As a polynomial. Now that's the most simplistic type that I could throw at you. But be really careful. If it's a monomial in the bottom, it has to distribute to each and every term in the top. Alright, now I gotta steal something from the book. You can't just make these up off the top of your head. Bad things happen if I do. So we did that one, Let's try this one. Number 10. Curious what happens. 6x squared minus 31x plus 5, and we're going to divide that by x minus 5. Kind of a simplistic problem. Now, to divide a trinomial by a binomial, you have to use long division. Y'all remember long division, right? So, this is the calculator generation. So, if you were going to take 12 and divide it into, let's say, 200, 2,000, whatever. I won't finish the problem, but we'll get it started. What's your first step?
12 goes into 20 one time.
12 goes into 20, how many times? One time. So you put a 1 up here, and then you go 1 times 12 is?
12.
And you write it down here. Then what do you do with it?
Subtract.
Subtract it. And 20 minus 12 is?
8.
8. And then you
0.
drop down to 0. And then you say 12 goes into 80 how many times?
7. No, 6.
6 times 9, or 12 is?
72.
72. So 6. 6 times 12 is 72. And then you take it and subtract. That becomes 8. And then you bring down 0 and it becomes 6, 6, 6, 6, 6, 6, 6, forever and ever. Okay, so that's the idea behind doing it with polynomials, because x minus 5 is just a... Goes back to that definition of what algebra represents. What's algebra represent? A number. So x minus 5 is just a number, and it's being divided into another number, so it should follow the same laws as numbers. So long division should work perfectly fine. So we're going to set it up as x minus 5 is going to divide into 6x squared minus 31x plus 5. I highly suggest you waste space. Do not write this really, really small, because you will find that you get confused eventually. I think it's this one. All right. How do we start this? Well, over here with 12, we said, well, 12 went into 20, and we could figure that out. This is a little trickier, because I'm not going to sit there and go, x minus 5 goes into 6x squared. That just doesn't make any sense. So I'm going to take it as just the first term. What do I multiply x by to come up with 6x squared? 6x. So I'm going to put that on top. Now, once I put it on top, it's going to multiply the, oh, by the way, what is that one called? Well, what's the 12 called? There's names for these things.
The divider.
Divisor. Divisor. What's the 2000 called?
The dividend.
The dividend. The 16?
The answer.
No. Begins with a Q.
The quotient.
Quotient. And 80, well, whatever comes out at the
Remainder.
bottom would be the remainder. So we have this divisor going into a dividend. It's going to give me a quotient. So when I get this part of the quotient, it's going to multiply what's sitting out front. But if it's going to multiply what's sitting out front, it's going to hit the x, but it's also going to hit the negative 5. You have to distribute it over x minus 5, because it's multiplying it. So 6x times x is 6x squared. And then 6x times negative 5 is negative 30x. What was the next step on regular long division? You multiply it down,
Subtract.
then you subtract it. So I have to take this whole thing and subtract it. Okay. Now what's supposed to happen is the 6x squares are supposed to cancel. Oh, by the way, what properties are cancel?
Distributive.
Inverse and, well, what happens? You get 6x squared minus 6x squared, which is? Identity is the other one. Inverse identity is just a shortcut. So they cancel, and you get negative 31x. What's this one turn into?
Positive.
Positive 30. So if you want, you can put a little plus sign there. And you get negative 31x plus 30x, which is better known as?
1x.
Careful.
1.
Negative 31 plus 30. Negative 1x. And then you bring down
The 5.
the positive 5. And you start all over again. What times x is going to give you negative x? What times this x way over
Negative
here?
1.
Negative 1. So I'll put negative 1 into the quotient. And I'll go negative 1 times x is negative x. Negative 1 times negative 5 is
Positive 5.
positive 5. And then I'm going to take this and subtract it. What's my remainder?
0.
0. My remainder is 0. What happens when you divide numbers into each other and your remainder is 0? What do you call that? It divides into it. I always called it evenly. Divides evenly? No? People with calculators, they don't understand that anymore. So if 7 goes into 35, how many times does 7 go into 35? 5. And you go 5 times 7 is 35, and then you subtract them and you get 0. What the heck does that mean? There's some meaning here. It divides them evenly, but it also tells you that 35 can be written as
35.
7 times 5. The divisor times the quotient. So what happens when you take a number, you divide it evenly? What do we call 7 and 5 of 35? When you take a number like 6 and you break it down into 2 times 3, what do we call that? Factors. 2 and 3 are factors of 6. 7 and 5 are factors of 35. Well, here we got a remainder of 0. So the divisor, x minus 5 is one of the factors. What's the other factor?
6x minus 1.
6x minus 1. And if I multiply them together, what should the answer be?
6x squared minus 31x plus 5.
6x squared minus 31x plus 5. What is this called? Factoring. It's like one of the first steps of learning how to factor. You do division to figure out what times what is equal to what, especially when the numbers get a little bit bigger. Pieces to it. 22. 18x to the 4th minus 5x squared minus 11x plus 8, all divided by 3x minus 1. So far, this one's going to be the most important because it has 2 things in it that the other ones do not have. Well, I'll do it here. So we set it up, 3x minus 1, and it's going to go into 18x to the 4th minus 5x squared minus 11x plus 8. So start off like normal. What times 3x is going to give us 18x to the 4th? 6x cubed. So I'll put 6x cubed up here. Okay. So 6x cubed times 3x is our 18x to the 4th. 6x times negative 1 is?
Negative 6x cubed.
Negative 6x cubed. And then we're going to take it and?
Subtract it.
What's wrong with this? These don't match up. This is 5x squared. This is 6x cubed. So what's going to happen here is something's wrong. Something's missing. What's missing? Well, I can't do this because they're unlike terms. So if I want a like term, I need to change something on the top. What do I need in the top so I can subtract? Well, actually, subtract a negative 6x cubed.
Another exponent.
I need an x cubed in the blue part. I need 18x to the 4th plus something cubed. What can I put in there? 0. I need a 0 in there, a placeholder. You know, like numbers like this. That 0 represents absolutely nothing other than a placeholder. It just tells you have 0. What do we have 0 of?
0 tens.
0 tens. So here I need a placeholder to hold on to the cubed spot. So I can't write the problem this way. I have to actually write it a little longer. So we start over again and we say 3x minus 1 is going to go into 18x to the 4th.
Minus 0.
Nope. Well, you might as well just do plus 0 what? X cubed. That way it doesn't affect anything because 0 times x cubed is? 0 times x cubed?
0.
Is 0, and 0 plus anything doesn't change it. It's an identity. So writing it here doesn't change anything about the polynomial. It just makes it look a little longer. 5x squared minus 5x squared minus 11x plus 8. Now we can do it. Because when we multiply through that 6x cubed, put it back up here, 6x cubed, we're going to get our 18x to the 4th, and we're going to get our negative 6x cubed, and we're going to subtract it away, but now I can subtract it because the powers line up. 18x to the 4th minus 18x to the 4th is 0. That's supposed to happen. 0x cubed, remember we have to change the sign, plus 6x cubed.
Negative 6 cubed.
Plus 6x cubed. It's going to be positive. Remember, you have to change its sign. So this becomes 6x cubed, bring down the negative 5x squared. And now it works rather nicely. And then you continue on your merry way. What times 3x is going to give us 6x cubed?
2x squared.
A positive 2x squared. Get used to saying positive and negative. It's really important to get the signs in there. So a positive 2x squared times 3x gives you the 6x cubed. The positive 2x squared times the negative 1. Positive 2x squared times that negative 1. Negative 2x squared. And notice the powers lined up rather nicely again. So we're going to take this and subtract it. Remember when you're subtracting it, this isn't always going to be minus. This like negative 2x squared here, sometimes it's plus and you have to change it into minus. Here we're going to change it into a plus. So this is negative 5x squared plus 2x squared. Negative 3x squared, and drop the next number, negative 11x. The next term. All right. What times that 3x way over here to the left is going to give you negative 3x squared down here? Negative x. All right, so negative x. Negative x times 3x? Negative 3x squared. Negative x times negative 1? A positive x. And then we're going to subtract it. So here comes that option where we have to change the sign again. So instead of a positive x, we're really going to change it to a negative x. So the 3x squares are going to cancel. Negative 11x minus another x is negative 12x. And bring down the next number. Plus 8. This isn't that bad. All right. And finally, what times 3x is going to give us a negative 12x? If it's negative 4x, it'll be negative 12x squared. So you want just negative 4. So negative 4 times a positive 3x is a negative 12x. Negative 4 times negative 1 is? Ooh. Is it plus 8? Yeah, plus 8. Plus 4. I wanted that plus 8, but hold on. And we're going to take this and subtract it. Seems very redundant that we keep subtracting that, but that's all right. And then the 12x's will cancel. The positive 4 turns into negative 4. 8 minus 4 is 4. So this has a remainder that is not 0. So that means if I multiply 3x minus 1 times 6x cubed plus 2x squared minus x minus 4, I'm not going to get the polynomial that's underneath because it's off by 4. So the second part of this, they read it the right way. The second part is, what does it mean to be divided with a remainder? So for instance, 7 goes into 24. How many times does 7 go into 24?
Why do you keep changing the sign from a positive? That was a positive 4. Why do you make it a negative?
Because this big minus sign sitting up front. You're subtracting the entire polynomial, so you're distributing. A negative 1 times negative 12 is positive 12, so the negative 12 and the positive 12 become 0. And negative 1 times positive 4 is negative 4. I'm changing all the signs. When you put a negative sitting up front, it changes everything in the inside. Do you trust me? You don't trust me. So negative 1 times negative 12x plus 4 Distributive. Negative 1 times negative 12.
Positive 12.
Positive 12x. Negative 1 times positive 4.
Negative 4.
That's why I have this negative 4 here. It's just a shortcut method instead of writing it all out. Just go through and change all the signs. All right. 7 goes into 24 how many times? 3. 3 times 7 is 21. Subtract and you get a remainder of 3. What is the answer?
Distribute.
What is the answer? What does this all mean? When you type this in a calculator, you get a decimal, right? So the decimal must be part of the remainder. I guarantee that it's not 3.3. Go ahead. Divide 24 by 7. What do you get? It turns out to be 3.3. I'll be really shocked. 24 divided by 7. There we go.
3.428.
Blah, 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 blah. An ugly decimal. So where is that ugly decimal here?
3 over 7.
It's 3 over 7. So how do I write this as an answer? 24 is equal to what? I'm sorry, 24 divided by 7 is equal to what?
7.
No.
3
I mean 3 and 3
3 and
3 7.
3 sevenths. The 3 sevenths is where that 0.4 whatever is coming from. If you do 3 divided by 7, that'll be exactly the same decimal. So this part right here, that's actually the remainder. And one thing I hate about how you learned long division with numbers is a lot of the teachers allowed you to get away with saying remainder 2, remainder 3, remainder 4, and not really explaining what that remainder was all about. It actually is 3 and 3 sevenths. So over here, since I have this remainder of 4, my answer is a little strange. It's the quotient, so you get 6x cubed plus 2x squared minus x minus 4 plus the remainder, because 3 and 3 sevenths is the same thing as 3 plus 3 sevenths. It's exactly the same thing. So what's my final part of the answer? Well, it's the quotient plus this divided by 3x minus 1. You write it plus 4 divided by 3x minus 1.
You can't just write a big R.
Nope. Nope. We're out of 4th grade. You have to write it properly. That is the proper way of writing the answer. So it's the quotient plus the remainder divided by the divisor. Quotient plus the remainder divided by the divisor. And it's not a hard thing to remember. You just have to go this divided by that to tip it off. Obviously, 0 does the same thing, but 0 divided by 3x minus 2 is still 0, so you don't have to write anything. Let's see. Do one more of those?
Sure.
Make you do it?
No.
No.
I'm going to form and do it.
Make you do it. How about this one? I'm going to adjust 24. So this is kind of like 24, but I'm going to make it a little different. 2t to the 4th plus 5t cubed minus 11t squared minus 20t plus 12. And we're going to divide this by, maybe I won't change it, t squared plus t minus 6. I think we should leave this one alone. I was going to force another remainder on it, but I decided differently when I saw the bottom.
That's not.
Yeah, that's a lot. We'll do this together, but hopefully you'll follow along. So, the divisor is t squared plus t minus 6, a trinomial. T squared plus t minus 6. And it's going to divide into 2t to the 4th. Oh, before you even write this down, I highly suggest you do this. Are there any missing powers?
No.
No. It goes 4, 3, 2, 1, none. If there was a missing power, I highly suggest you put it in. Like if there was if this was 2t to the 5th, you better put in 0t to the 4th. Get all the powers listed out when you're writing your polynomial down. That way you always have something to line up with all of your answers. All right, so we got 2t to the fourth plus 5t cubed minus 11t squared minus 20t plus 12. Okay. Ooh. Or, that's okay. They're not hard, it's just sometimes they take a little more writing. But the essence of it stays the same. You concentrate on just the t squared for most of this problem. What times t squared will give you 2t to the fourth?
2t squared.
2t squared. When you multiply it out, you're going to have to multiply it over the trinomial. So you have to hit each and every one of those terms. So you're going to have to hit the t squared and the t and the -6 to get your subtraction part. All right, so 2t squared times t squared. 2t to the fourth. 2t squared times positive t. 2t to the third, and it lines up rather nicely under 5t third, so plus 2t to the third. Don't forget to say positive and or negative to get your signs right. Then 2t squared times -6. -12t squared. And then we're going to take this whole thing and subtract it. So our colored pencils come in handy. Draw a line. What am I going to do to every term on the inside of this green thing? Change its sign. So this becomes, if you wanted to, you can change that to a plus. This becomes a minus. This becomes a minus. This becomes a plus. You change all the signs all the way across. All right, the 2t to the fourth. Cancel. 5t cubed minus 2t cubed is 3t cubed. -11t squared plus 12t squared plus t squared. And then what? Bring down that -20t. So -20t. The next term. Drop it down. All right. And then start all over again. What times that t squared way over here to the left is going to give me 3t squared, or 3t cubed. 3t. So a positive 3t. So 3t times t squared. 3t cubed. 3t times positive t.
3t squared.
Positive 3t squared. Get the same positive. 3t times -6. -18t. And take this whole thing and subtract it. See what happens. First, change all the signs. So this becomes positive, this becomes negative, this becomes negative, and this becomes positive. Draw my line. So the 3t cubes cancel. T squared minus 3t squared.
-2t squared.
-2t squared. Be careful of your signs. -20t plus 18t.
Minus -2t.
Minus 2t.
Plus 12.
And drop down the 12. Whew. And then finally, what times t squared is going to give us -t squared? -2t squared. -2. So put -2 here. It'll give you -2t squared.
Minus 2t.
Minus 2t.
Plus 12.
Plus 12. And when we subtract it away,
And 0.
we get a remainder of 0. So what does that mean? Well, that means I took 2t to the fourth plus 5t cubed minus 11t squared minus 20t plus 12 and factored it. What did I factor it into? Well, I factored it into the divisor times the quotient. What's the quotient?
Answer.
2t.
2t squared plus 3t minus 2. And if I multiply those two together, what do I get?
That long answer.
That long thing, 2t to the fourth plus 5t cubed, dot, 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 dot. We get the whole thing. It comes out perfect because the remainder was
Well,
0.
you're looking for our answers. What are you looking for?
Your answer is going to be this piece here. the
So we
quotient.
don't need to go back and do.
No, but I'm trying to get it into your head that if you took the quotient and the divisor and multiplied it together, you get the dividend. You just get it. When the remainder is 0. Otherwise, you have to write it ugly style of the remainder over the divisor. All right. What time's it? Ooh, I have 5 minutes. Yeah. Which one was good? Too long. I don't have remainders for those up there. Let me make a blank. Force a remainder. This one's for you to do. It's a little short one. I'm adjusting, which one? Number 12. So this is like 12, but I'm making a slight adjustment to it. And I'll write it in out long division style. Divisor, dividend, and I want you to find quotient and possibly a remainder. Take 10 minutes while I'm doing that. Right, Sharon? Oh, you do.
Sounds so surprised.
My remainder's not 0. I know yours is. I don't know how though.
What about
Supposed to be that. The remainder is not 0. If you got 0, it's because you didn't do something right. The remainder is not 0. It's small. You have to
is it negative 4?
You just did something wrong. Instead of writing plus that, write minus. See the minus sign? See, right now it looks like times floated down in front. That's probably the only time I do float this sign down. Yeah, don't never do double signs. Just throw the main sign in front. See where people are making their mistakes. Ready? Here's the mistake that people are making. This is 3x, right? That'll give you 12x squared plus 3x. Then you take this whole thing and you subtract. Subtract it. This becomes a negative 12, this becomes a negative 3. When you add them together, the first two become 0, the second two become
Negative.
positive 8x minus 2. And then what times 4x is 8x? A positive 2. Distribute it out, you get 8x plus 2, and you subtract it away. A lot of people are looking here and going, oh, that's 0. But you forgot to change the signs. This becomes negative, this becomes negative, and the 8's will disappear, and negative 2 minus 2 is negative 4. And your final answer should be 3x plus 2. Put the minus sign here. fraction, put a 4 up top. That way you take care of, instead of writing plus minus, that gets kind of redundant. So it's a negative 4 over 4x plus 1. And that's the proper way of writing it. So be really careful to subtract when you get down there to the bottom. Change those signs. Alright. So that leaves